These are the notes for the intermediate value theorem. The intermediate value theorem is one of two existence theorems that are about finding the existence, proving that something exists. The second theorem that we will do later in the course is referred to as the mean value theorem. Right, so again, both of these are existence theorems. And the difference is that the mean value theorem is looking for the existence of a value. It's going to tell you that a value exists. It's going to be looking for a particular point on a function. And we're looking for the fact that the value exists. The mean value theorem is going to tell you that a slope exists. So it's looking at your curve and it's looking at a particular point, or looking for a particular slope, right? Slope of the tangent line, if you will. All right, so let's look at see, I get it confused. Let's look at the intermediate value theorem. So the intermediate value theorem says this, that if f of x is continuous, and the intermediate value theorem only works if you have a continuous function. So if f of x is continuous and we have some point D which is in between f of a and f of b, right? So we're thinking on the y-axis here. Then there is some point C on our x-axis such that f of C gives us the value D, there's their existence of the value, and that point C sits between A and B. Right? That's it. If you would like to just simply memorize that, then you'd be done with the intermediate value theorem. But it's probably a little bit better if you understand what's going on. So let's look at a picture here. Right? So here's our picture. We have, we'll draw a function in here, and what I want to do is the function is going to go through the point A, f of A, and it is also going to go through the point B, f of B. What it does in between those, I don't really care so much. So now what the intermediate value theorem is saying is that if we have a point somewhere between A and B, right? So let's say we have a point right here, we're going to call that D. So the intermediate value theorem is saying that if this point D is between our 2 points, f of A and f of B, two y values, then there must be some point C that's between point A and point B. And you can think about it as this. You start with point D, and we're working our way over to the function. We find the function, and then we work our way down till we find C. And that's what the intermediate value theorem says. So the key here is that we start with D, that's between f of A and f of B, and then it goes this direction. It goes over to the function, down to the x-axis, and then what we're able to say is, aha, there is a point down here called C that exists, and that point is between A and B. Right? So now if you go back and look at the definition, that's what that definition is saying. All right, so this is the definition. Hopefully it makes a little bit more sense. Hopefully you can see this picture and understand that there's a point C that exists for every point D in between two bounds, f of A and f of B. Let's look at a real-world example and show why the intermediate value theorem really just makes an enormous amount of sense. Because really all that it's saying is if you were to be looking at some function, say the function is how much you weigh, we're looking at how much you weigh over the course of time, and we're keeping track of how much you weigh while you're taking AB calculus. And on day 2 of your AB calculus course, you weigh 180 pounds. On day 10, you weigh 200 pounds. So the intermediate value theorem says you can pick a weight between 180 and 200 pounds. I'm going to pick, let's pick 195 pounds, which would be up here, right? And if I pick 195 pounds, what that means is somewhere between day 2 and day 10, I was at exactly 195 pounds. You can think about it this way. If I'm going to start here at 2 pounds, at 180 pounds on day 2, and my weight is going to go up, maybe it goes down, and maybe it goes up really quickly, maybe it goes down. But if at the end I end up at day 10 here at 200 pounds, somewhere along the line, somewhere in here, at least once, maybe twice, but at least once I have hit exactly 195 pounds, and that means that somewhere between day 2 and day 10, I was exactly 195 pounds. Pretty straightforward, pretty obvious, intermediate value. All right, here's another example of how you might use the intermediate value theorem, or actually I should say here is an example of how you might use the intermediate value theorem. I have this function f of x, and I want to know whether or not it has a root in the interval -3 to 3. So another way to ask this question, sort of in intermediate value theorem language, is there a point C? Does there exist a point C such that f of c equals 0? Or I'm looking for a 0 which is between f of a and f of b, and if there is a 0 between f of a and f of b, then there must be a point C that's between a and b. So let's go through and check this. So we'll start with the left bound. So we're going to start at -3. So if we have an x at -3, we can plug that in. -3 cubed, -27, minus 2 times -3 plus 1 gives us a -20, right? So at -3, the function is at -20. We can then look at the right bound, right? We can look at 3. We take that and plug it in. 3 cubed, 27, minus 2 times 3 plus 1, that's going to give us a positive 22. Not to worry, I'm not doing that quickly in my head. I've already computed these values ahead of time. So I've got on the one bound, -20 is my value of the function. On the other side, I've got 22 is the value of my function. And what I'm interested in, my 0 is in between those, so that means there exists a C, right? And that C is what I'm looking for. There exists a, a root, right? So this shows me that, yes, indeed, I have a root, which is a good thing to know because it'd be a shame to go chasing after a root if there didn't exist a C such that the function was equal to 0. All right, so let's finish by looking at a common mistake, common misuse of the intermediate value theorem, a way that people use the intermediate value theorem to say something that is not necessarily true. Right? So the intermediate value theorem deals with continuous functions. It deals with a point C that's in the interval a, b. So I'm going to take and just put a point C in this interval. Right? Now the intermediate value theorem says that there's a point f of c that's between f of a and f of b. The common mistake is to start with the point C, start down here with the point C, and make a statement about f of c. Right? So I found this c that's between a and b, and I'm going to make the statement that f of c is between f of a and f of b. Right? Take a moment here and see if you can't figure out, it shouldn't be that hard, what the continuous function looks like such that f of c is not between f of a and f of b. figure out one that works. You just need to get your continuous function to head up above f of b and then come back down to f of b such that f of c is not, right? So here's our f of c now. Our f of c is not between f of a and f of b. Right? The mistake here is that if you use the intermediate value theorem the wrong direction, if you start with c to go find f of c, you can't make any statement about where f of c is going to be. The intermediate value theorem starts with a point D and then uses that point D to go down to the x-axis to find the point C, and that point C is going to be between A and B if your original point D was between f of A and f of B. Last thing we want to look at is the precision that's needed in using the intermediate value theorem. So the intermediate value theorem is talking about the existence of a solution, if you will. In this case, we're looking for the existence of, we're looking for some c. Does c exist such that this function will be equal to 1/2 on the interval 0 to 5? If you take and you look at the value of this function on the interval, well, on the left end of the interval, when you plug in 0, you're going to get 0 minus 2 over the absolute value of 0 minus 2, which is going to end up giving you negative 2 over positive 2, a value of negative 1. On the right-hand side of this interval, you're going to end up getting 5 minus 2 over the absolute value of 5 minus 2, which is going to give you 3 over positive 3 over positive 3, so it gives you positive 1. So our value that we're interested in, the value of the function, is 1/2, and it is less than the right-hand side of our interval, the value at the right-hand side of the interval, and it's greater than the value at the left-hand side of the interval, which might lead you to believe, there is a c that's going to work here. The intermediate value theorem has two ifs to it. Let's just look at the second if. That's the one we just did, right? So the second if says that you have a d that's in between f of a and f of b. And then the conclusion, right, if the two ifs, and notice I've skipped that first if, but if the two ifs are true, then you get to make the existence conclusion, right? So then you get to say there is a c such that f of c equals, in this case, 1/2. In general, it's d, right? So that's the intermediate value theorem. The first if, though, is equally as important. The first if here is that the function has got to be continuous. If f of x is continuous. Now, this function, we can see pretty easily by looking at it, that when you plug in 2, you're going to get 0 in the denominator, and it's going to be undefined to add 2. 2 is on our interval. Therefore, this function is not continuous. The function is not continuous. The intermediate value theorem does not work, will not tell you anything about the existence of c. Both of the ifs need to be true. You need to have the function being continuous, and you need to have the value of the function be between your two endpoints of your interval. Right? And then just quickly, let's take a look at what this function looks like. Right? So this is the function that we were playing with, and you can see that it's a step function. So this function is never, ever going to be 1/2. Right? And the step is right there at 2, where the function blows up. right?